How are things organized? You can see some of the organization that I just took pictures of in my own house. Some would say that sometimes I'm a little over-organized on certain aspects. Sometimes I just can't be organized at all. But part of my organization, if we look at some here, like for instance my cabinets where I have my coffee and my teas and all my coffee mugs, and for some reason I decided to label those shelves. I also have an organization with my Band-Aids, separating my kids' Band-Aids from my regular Band-Aids, and using all of these baskets in one of my hallways. One of my favorite organizations is my pantry, where I have my snack shelf, my breakfast shelf, that's more my lunch shelf, and above it I even have my dinner shelf. Organization also can come in many different ways. I organized my coffee where I have the decaf down here in the middle, followed by my iced coffee, and then my other coffee. And you can see pattern of iced, decaf, and regular going down, and going down here it's all iced. So I have patterned both horizontally and vertically in my coffee arrangement. Even my organization has gone on to my daughter. If you look at my daughter's closet, she decided to do Roy G. Biv for her clothes, and I just love that. And the final best organization of all is what we're going to discuss today, is our periodic table. Periodic table is not just randomly placed elements. They have order and organization. Let me introduce you to one of my heroes, Mendeleev. At first glance, you might think that Mendeleev is kind of a creepy guy, and you know what? He is. Look at him. Oh my. But Dmitri Mendeleev, he is the person that we have to give credit to for our organization of the periodic table. He was a professor of chemistry at the University of St. Pittsburgh, and when he couldn't find a textbook to suit his needs, he decided to take some known elements, about 60 of them, and put them in some kind of an order so that he could teach his students better. You can see his drawings are a work in progress, shall we say. Not sure if I like all of his cross-offs, but it's definitely signs of thought and process going into this table and his organization. Here's an example of what Mendeleev's table looked like. He created this table back in 1869. He was able to arrange the periodic tables according to their atomic mass and also how reactive they were with other elements, according to their reactivity. Reactivity is how easily an element will react with another substance to form new compounds. An element that is highly reactive is sodium. If you take some sodium and put it in contact with water, it'll react vigorously. Sodium reacts with water, as so does lithium and potassium and rubidium and cesium. You can see that he lined these up all along the row here, showing that they were reactive, and there's lithium. He used the properties of elements and their atomic masses and arranged them in some kind of orderly fashion. He was also able to make predictions, indicated here with the question marks, about elements that had not yet been discovered. He knew, according to their atomic mass and their property, that they must exist. A lot of people weren't believing him. How could you make predictions about things that weren't there, is what people asked. But only a few years after his table was published, new elements such as gallium was established and discovered as being one of the missing and unknowns. Today's periodic table is this one. We use a lot of Mendeleev's organization, but no longer are we organizing our periodic table according to mass. We are organizing the periodic table according to the atomic number, which is the number of protons. A few of these become out of order according to their masses. The periodic table we use today was arranged by Henry Moseley. Here is a periodic table square representing an element. Up at the top, you're going to see where it says the element's name. The name can be represented and usually is not even printed on a periodic table. What is printed on the periodic table is the atomic number. The atomic number indicates the number of protons and electrons in an atom. The atomic symbol is represented in the middle, and in this case, capital M, lowercase o, and finally the atomic mass. The atomic mass is comprised of the number of protons plus the number of neutrons. Here is an example where you can have the opportunity to fill in what is represented on this element square. Take a second and complete and fill in the arrows. This would be a good opportunity for you to write these down in your notes before I give the answer. Let me go over the answers. Hopefully you are finished. We have the atomic name or element name. Let's call it the element name instead. Element symbol. Atomic number, which is also the number of protons, and the atomic mass, which is the number of protons plus the number of neutrons. Oops, had to squeeze it in there. How well did you do? The atomic radius is another way that the periodic table is organized. The atomic radius increases as we go down a group or a family, and it decreases as we go across. We are going to explain this concept on why this happens in class. Another way that the periodic table is organized is by something called electronegativity. The word electronegativity means it's love of electrons. How much does an element love its electrons? If it loves its electrons a lot, it has a high electronegativity. The highest electronegativity is fluorine. Fluorine loves its electrons so much that it's really difficult to take them away from him. He just loves his electrons. Therefore, the pattern for electronegativity is increasing towards fluorine and it decreases away, or you can think of it as it increases this way. And a final way that we are going to study how the periodic table is organized is called the ionization energy. Ionization energy is defined as how much energy it takes to rip off or pull an electron from that outer shell. Now, if you remember, fluorine just loves its electrons so much, it would require a lot of energy to take it away from him. He does not want to share his electrons. Therefore, the energy increases going towards fluorine both ways. Increases going across a group and increases from the bottom up. Fluorine has the highest ionization energy. This is just a quick video on Dmitri Mendeleev, his contribution to the periodic table, and a small tidbit of how it is organized. Our next lesson is going to start covering Lesson 10, which is all about the periodic table and the groups and families. We are going to get to know the periodic table better.